This video will cover translations in geometry. A translation is represented by the notation T subscript A comma B, where it's a slide left, right, or up, down using addition and subtraction. So our rule here would take x comma y, some point, and map it onto x plus a comma y plus b, where a and b are the rules of the translation that tell us to move up, down, left, or right. And of course, if we're moving left and right, that's related to the x, and if we're moving up and down, that's related to the y values. So here we'll just see a basic translation in example 1, where we are given a triangle ABC with vertices -3, -1, 2, 4, and 5, -2. So just take a second to plot those points. Remember, we always think about coordinates as x comma y. They are in alphabetical order. X comes before y. So I must go left 3 and then down 1. When I plot it, I'm going to label it with its letter. So I have A at -3, -1, B at 2, 4, C at 5, -2. And then I just connect them to make a triangle. And if you have a straight edge, try to use it. If not, then of course you're just kind of eyeballing it, and it might be messy like mine. Here it says to graph the preimage. Remember, the preimage is just your original triangle, triangle ABC. And its image, that's the new one, triangle A prime, B prime, C prime, after the transformation of 2, -4. And remember that capital T again means translation. So I'm going to be sliding over 2 and then down 4. And by over I mean right, because it's a positive 2. So I'm going to move right 2, down 4. And we're going to first see this graphically, and then we'll talk about how to do it algebraically. So I'm going to take each point, count over 2, down 4, and then plot its new image. So I'm going to take A, count over 1, 2, and then down 4. 1, 2, 3, 4. And so I'm plotting the point right here, A prime. It's important that you label the new coordinates so that we know where those points are. B, right 2, down 4. 1, 2, 3, 4. Becomes B prime. C goes right 2 and then down 4 and becomes C prime. So then I'm connecting. And my last step is to list the coordinates of triangle A prime, B prime, C prime. So I'll do that over here off to the side. A prime is at -1, -5. B prime looks like it's at 4, 0. And C prime is at 1, 2, 3, 4, 5, 6, 7, -6. So this here would be my final answer. Now I also want to talk to you about how to do this algebraically. So if I didn't remember that I needed to move right 2 and down 4, and all I knew was I had the coordinates, and maybe I didn't even have a graph. So we can do this algebraically by listing the original points, and then I'm going to think about this translation in terms of addition and subtraction, as we mentioned earlier, addition and subtraction. So I'm going to take each x term and add 2, take each y term and subtract 4, because the rule, remember, was telling me to take x's and add 2, take y's and subtract 4. So now I have A prime at, well, -3 take away, or I'm sorry, -3 add 2 is -1. -1 take away 4 more is -5. And you can see that our A prime here matches up with our A prime here. So we're getting the same answer even though we're doing it algebraically instead of graphically. So again, I'm going to take these x and y's, add 2 to the x, subtract 4 from the y. B prime lands at 4, 0. And C prime, I'm going to do the same thing. 5 plus 2 is 7. -2 take away 4 more is -6. So again, same answer. It's just one way is doing it algebraically, the other way is doing it graphically. Our next question here says, what properties remain invariant? And if you think back to the vocab that we had at the beginning of this unit, invariant means stays the same. In a translation, there's many properties that remain the same, and the most important one is here is the size. Another word for size is distance or length. Additionally, the angle measure stays the same. All I did was slide triangle ABC over to make a new image, and angle A, for example, is the same measurement as angle A prime. Additionally, we also know that the orientation stayed the same. Orientation is just a fancy way of saying order of letters. So if I were to read the letters on my triangle above, going clockwise starting at A, my original triangle would read as A, B, C. If I do the same thing starting at A prime and reading clockwise, my new triangle reads as A prime, B prime, C prime. So the letters are in the same exact order. There's other properties such as parallelism that stay the same, along with several more. But just to name a few of the important ones, we really want to focus on the size, the distance or length, and the orientation. If we think about properties that change, there's really not any besides location, so I'm just going to say none. Location doesn't really count as a property. We're going to move on to example 2. Identify the rule and apply. Given the preimage point A at 8, -2, and the image point A prime at 5, 4, what are the coordinates of the image of point B after the same translation? So our first step is to find the rule. That looks like find cool, so let me make that an R. Find the rule. And so here I'm given point A at 8, -2, and A prime at 5, 4. And I have to figure out, how do I go from 8 to 5? How do I go from -2 to 4? So if I look at going from 8 to 5, it looks like I'm subtracting 3 from the x values. To go from -2 to +4, it looks like I have to add 6 to the y values. So it looks like my rule is taking x, y, and mapping it on to x minus 3, y plus 6. Another way to write this, because we know it's a translation, is to use that notation, capital T, -3, 6. Either of these two options are acceptable. Writing the rule out using x, y maps to, or writing the rule out using the translation notation. So now I have to apply it to point B. So I have B at -4, 2, and I want to apply the rule -3 plus 6 in order to get B prime. -4 take away 3 more is -7. 2 plus 6 gives me a total of 8. So B prime, after the same translation, is located at -7, +8. Our next example has us working backwards. Given the image B prime, so they give us what we usually get out. We are given the image B prime that has been transformed by the rule xy maps onto x minus 3, y plus 1. What are the coordinates of the preimage point B? So I need to work backwards here. I'm trying to go from B prime at 4, -3 onto B at some point. Now, to go from B to B prime, they're telling us that we used this rule, x minus 3 and y plus 1. But I'm trying to go backwards. So instead of doing x minus 3, I'm going to now take x and add 3. I'm going to do also the opposite for y plus 1. I don't want to add 1 because that would get me even further from B. I want to subtract 1 so that I can land back on top of B. So if I do this, I have 4 plus 3 to give me a total of 7, and -3 take away 1 to give me a total of -4. And if you want to check yourself, we have 7, -4 here. And if you want to check yourself, we can just apply the rule that they gave us. Take away 3 from the x's and add 1 to the y's. That would put me back at B prime. So I did my work correctly. I worked backwards by doing the opposite. So if it's a subtraction sign, I should use an addition sign. If it's addition, I should use subtraction, doing the opposite. On the next page, you'll find your practice problems. So you can pause this video, rewind if you need to, but the practice problems are pretty similar to what we just looked at in this video. So go ahead and take a few minutes to try them on your own before you move on to the next topic.